Now that we are done with the information for the test 3, which was chapter 6, we're moving on to chapter 7. And the first section we're going to look at involves the law of sines, 7.1, as this says here. So we have left behind the world of these right triangles, and now we're looking at these next topics because we're not in that world of right triangles anymore. We're in this world of oblique triangles, which means a triangle that does not have a right angle. So as it says here, we're looking at a triangle that either has 3 acute angles or possibly 2 acute angles and 1 obtuse angles. So because we're not involving triangles that have a right angle, we can't use all that we know about right triangles. So in other words, there is no a squared plus b squared equals c squared. Can't use that Pythagorean theorem anymore because there is no right angle. Also, no SOHCAHTOA. So no sine being opposite over hypotenuse, or none of the trig functions work here as we've defined them before because we don't have that right triangle. So what we are going to have to help us with these is the law of sines. So before I get into that, just here I have some examples of some obtuse triangles. In this example here on the left, we have 1 obtuse angle. Remember, an obtuse angle is greater than 90 degrees. And then 2 acute angles. And in this particular triangle here, we have 3 acute angles, all less than 90 degrees. And while I'm looking here, let me point out just some use of symbols here. In these triangles, we're going to use A, B's, and C's when the letters are uppercase. So here A, B, and C. When they're uppercase, that means it's the measure of the angle. And when it's a lowercase letter here, A, B, C, that means it's the length of the side. So big A means angle A, and little a means the length of A. And notice little a, the length of side A, that's the side opposite angle A. So getting back to this law of sines, the law of sines is all about ratios. And it's all about ratio. So what the law of sine tells us is if we know some angle and we know the length of the side opposite, we can make a ratio with that. So here, the length of side A over the sine of angle A, this ratio is going to hold for all the angles and sides of the triangle. So A over sine of A is going to be equal to B over sine B, and it's also going to be equal to C over sine C. So these ratios hold for every angle and its matching side. So let's take a look at the first example here. We're given this triangle, and in these particular examples, what we're going to see is this SAA here. What this says is that A's are angles. So for this example, we know 2 of the angles in the triangle, and we know 1 of the sides. So our mission here is to, when it says solve for the triangle, when we're finished up, we want the measures of all 3 angles and all 3 sides. So in this example, we know angle A and angle C. So here's angle A and angle C. And we know that the side opposite C, or length C, is 14 centimeters. So what I'm thinking is we need all 3 angles. And to me, the easiest way to get started with this is, since we know 2 of the angles, I'm going to start by solving for my third angle, which is angle B. So we know that all 3 sides of a triangle, all 3 angles of a triangle always equal 180 degrees. So A is 64 degrees. We don't know B. C is 82 degrees, and this all equals 180. And for this particular problem, I will add 64 and 82. So B, and 64 plus 82 plus 146 degrees is 180. So B is going to be equal to 34 degrees. Subtract 146 from both sides, and there's our angle B, 34 degrees. So we have all three angles. And now we only have one side, side C. So we need to find the other sides of this triangle. So to do that, because we don't have our 90-degree angle, we can't do the usual sine and cosine and figure out the information that way because no 90 degrees. So we have to use this law of sines. So what information do we have? What ratio do we have that we can start with? Well, we have angle C and side C. So that's the ratio we're going to start with. So we have C over sine of C. And from our particular example, this is 14 over the sine of 82 degrees. So we always start with the information given for our ratio. And now we can either solve for A or B first. I'm going to solve for A. So this ratio is going to be equal to the length of side A over the sine of A, which is 64 degrees. So before, when I said we could start with either, I need to clarify there. We need to start with the information that we're given. So here we don't, I'm starting with A because I was given A here. I could use the B, but I'm going to start with A since that's what I was given. So here's our two ratios. So to solve these, we can do a cross multiplication like this. And so what we have is 14 times the sine of 64 degrees is equal to A times the sine of 82 degrees, cross multiplication. Now, to solve for A, I'm going to divide both sides by the sine of 82 degrees, sine of 82 degrees. So A is going to be equal to 14 times the 64 degrees over the sine of 82 degrees. So when we put this in our calculator, and be careful, make sure that your mode is in degrees and not radians, we get A is approximately equal to 12.7. Because our problem here says solve to the nearest tenth, it's going to be 12.7 here. So we have side A. Now, to solve for side B, we're going to repeat the same process. We're going to use this C over sine C. So we're using this 14 over sine 82 degrees. I'm going to use the same information that's given. And now this is going to be equal to B over the sine of 34 degrees. So set up the ratios. Again, we do a cross multiplication. And now we have here 14 sine 34 degrees is equal to B sine 82 degrees. So cross multiplication, and now B is going to be 14 sine 34 degrees all over the sine of 82 degrees. And so when we do this in our calculators, we get B is approximately equal to 7.9. So we have 1, 2, 3 sides, and we have 1, 2, 3 angles. So that example is done. Moving on to the next one, here's another oblique triangle we want to solve for. And here is the information that we're given. And I have put this information onto my picture here so we can see clearer what this information is saying. Here's our angle A. Oh, label here, A, B, and C. So here's our A, 40 degrees. Here's our C, 22.5 degrees. And here's our side B, which is 12. Again, we want to solve for all three sides and all angles. So again, I like to start with the angles because I find them easier in these problems. You can start with the sides if we want. We know all three sides of a triangle is equal to 180 degrees. In this case, A is 40 degrees. Oh, look, another problem. I didn't mean to do that. In both these examples, it's the B that's missing. I should change that up so we don't get so bored. B is, we don't know again, and then C is 22.5 degrees, and this is all 180 degrees. So when we subtract 40 and 22.5 from 80 degrees, we get, 180 degrees. B is 117.5 degrees. So we've gotten all our angles. Again, to solve for the length of the sides, we can't use Pythagorean theorem or anything because we do not have any right angles. So we're going to use the law of sines again. So here, the information that we are given is we have side B and we found angle B. So this is the ratio we have to use because it's the only pair that we have that's complete with a side and its angle. So we are going to have B over sine B, which is our 12 over sine of 117.5 degrees. There's the ratio we're going to start with. And I'm going to start with A. This is going to be equal to the length of side A over the sine of angle A, which is 40 degrees. So here, when I do my cross multiplication, I get 12 sine 40 degrees is equal to A sine 117.5. And then when I divide both sides by the sine, so I'm just going to do this here, sine 117.5 degrees and cross that out here. And now A is going to be approximately equal to 8.7. Again, we're going to the nearest tenth, so 8.7. Now we have A, and last but not least, we need to solve for C. So starting again, we're going to use this ratio here. So our 12 over sine of 117.5 degrees, there's our B over sine of B, and this is going to be equal to now C over the sine of angle C. Angle C is 22.5. Our ratio is set up. We do our cross multiplication. 12 sine 22.5 degrees is equal to C sine 117.5 degrees, and divide both sides by the 117.5, or sine 117.5 degrees. So C is equal to this here. So C is approximately equal to 5.2. And when you do these videos, what I recommend is haul those calculators out and do the calculations yourself to make sure that you are doing them correctly.